Page 368 in your books. We're looking at multiplying radical expressions. If you multiply two radical expressions, first of all, pay attention, they have the same index. If they have the same index and you are multiplying them, you can just multiply what's inside. Okay? So if you're multiplying like indexes, you can multiply what's inside. For example, square root of 2 times square root of 8. That is the square root of 2 times 8, which is the square root of 16, which has a root, which is 4. All right? All right, so for this one, cubed root of negative 5 times positive 25. That is the cubed root of negative 125. All right? That has a cubed root. The cubed root of negative 125 is just negative 5. All right, negative 5. All right, last one. Square root of negative 2 times the square root of 8. Negative 2 times 8. That's the square root of negative 16. I have a problem.
It's fine. Even it's not right.
Yeah, I cannot do negative if I'm talking about real numbers. Does not exist. We do not have a real number that is the square root of negative 16. All right, so this one right here, 72 x cubed. All right, they want the square root. And so 72 does not have a perfect square root, in case you did not know that, right? So we are going to use, for our numbers, we are going to use our factor tree. So we are going to use our factor tree right here. So we're going to say 2 and 36, right? 2, 18, 2 and 9, 3 and 3. Our index tells us how many times it has to group to come out of the radical. It has to group twice to come out of the radical. So these can come out of the radical. There we go. We can pull a 2 out. A 3 can come out of the radical, so we can pull a 3 out. This guy cannot come out. He's going to stay in. All right, and so inside my radical, I'm going to have that 2 there, okay? Now, for the variables, we're going to do the same method we did before with division. So we have x cubed. So let's look at what happens with him. We're going to take our 3 and divide it by 2. How many times does 2 go into 3?
1.5.
One time with we're going to use our remainder of 1. All right? Now, this number, the number that it divides by, is how many come out. This number is how many stay in. Okay? So for my x's, I have 1x that comes out and 1x that stays in. All right? That's how I do those. Now, if you have multiple things come out, you just multiply them. So you have 2 times 3 times x. So on the outside, I'm going to have 6x. If you have multiple things stay in, you just multiply them. 2 times x is just 2x. And that would be how I simplify that. All right, let's look at this one. All right, 80. We are going to use our factor tree. 2, and I always put primes on the left-hand side because if I do like 8 and 10, then sometimes I have numbers within it that I lose. So you'll notice I always use the smallest number possible that is prime and do it on the left-hand side so that I don't lose them within my factor tree. So I would say 2 times 40, 2 times 20, 2 times 10, and 2 times 5. All right? My index, what grouping can come out? How many times can it group?
3.
3, so 2, 2, and 2, right? So this is a group of 3. This does not have 3, and this does not have 3, okay? So I'm going to have a 2 that's on the outside, And on the inside, I'm gonna have a 2 and a 5. All right, let's look at my x's, or my n's rather, into the 5th. So I'm gonna say 5 divided by 3. How many times does 3 go into 5? 1, and my remainder is 2. So this is what comes out, this is what stays in. So for my n's, I have 1 n on the outside, and I have 2 n's on the inside. When I simplify this, 2 times n, that's 2n. On the inside, 2 times 5 times n squared, that is 10n squared. And make sure you put your index there, 3. And so this answer would be 2n cubed root of 10n squared. Let's look at this last example with multiplication here. All right. Now I want to tell you the easiest way to do this. All right. When I do these, I actually do this big thing here, 3. And for my 54 and 5, I just do 54 times 5. I don't worry about that. Then I combine my variables, x squared and x cubed. That's x to the 5th. Y cubed and y to the 4th is y to the 7th. All right. The reason I don't multiply my 54 and 5 is I'm about to a factor tree, which will give me 5 and 54. So I'm just like multiplying to divide at that point. You're welcome to multiply your 5 and 54, but you are about to then take a factor tree of 5 and 54. So you can actually take those factor trees individually. This guy is just 5 times 1. He's already prime. This is 2 and 27, 3 and 9, 3 and 3, right? Make sense? And I am looking for my cubed root. So I'm looking for things that group 3 times, all right? So for this one, I have these that group 3 times, right? This does not have a group, and this does not have a group. So a 3 is going to come out, right? And a 5 is going to stay in. For my 5 here, I will just do my method of division here.
Wait, two doesn't go in either?
It does. Hang on. 5 divided by 3. 5 and a 2. So 5 divided by 3 is 1 with a remainder of 2.
My bad.
All right. For my y, I have 7 divided by 3. That is what?
2.
With the remainder of 1. So for my variables, x's, I have 1x that stayed out, 2 x's that went in. For my y's, I have 2 y's that came out, 1 y that stayed in. And then I'm just going to simplify it. 3xy squared on the outside, 10x squared y on the inside.
You have to have the
Here, so for this one right here, you have a 3 and a 2 on the outside. Those start out on the outside. 3 times 2 is already on the outside before you take anything out. All right, so on the outside, I have the 3 and the 2. So I went ahead and put those out there, 3 times 2. On the inside, I have 7 times 21. X cubed times x cubed, that's x to the 6th. And a y squared, that's by itself there. 7 and 21, so 21 is 3 and 7. And I can group these two 7s, right? Because I have 1 7 from here and 1 7 from here.
You can group those?
Yep, so these 7s come out. This 3 stays in. 6 divided by 2 is 3. No remainder, so the 3 comes out. 2 divided by 2 is 1 with no remainder, so the 1 comes out. So I have 3 times 2 times 7, that's 42. X cubed y, square root of 3. So dividing works very much the same. When you are dividing two radicals, as long as they have the same index, you can just either put them together first if it helps, or do them individually, whichever is easier, okay? And so like for the first one, I do not have a perfect cubed root for 4. All right, so I'm going to actually simplify these first. So I am going to take the cubed root of 32 divided by negative 4. What is 32 divided by negative 4? The cubed root of negative 8 does exist. I can now simplify that to just be negative 2.
Way to go, guys.
All right. Let's look at this one. This one is the cubed root of 162x to the 5th divided by the cubed root of 3x squared. I can do these reduce first. All right, so 162 divided by 3. 3 into 16 is 5 with a remainder of 1, so 3 into 12 is 4. I reduce x to the 5th and x squared. 5 minus 2 is 3. So now I have this, all right? 54. If I don't know it, I'm going to do this, right? 2 and 27, 3 and 9, 3 and 3. I'm looking for something that groups 3 times. 3 is going to come out. 2 is going to stay in. For this guy, I'm doing 3 divided by 3. That's just 1 remainder of 1. So an x comes out, no x's go in.
Wait. 1 remainder.
I said it, I wrote it and wrote it wrong. That's a 0. 1 remainder of 0. That would be my answer. 3 comes out, x cubed comes out, 2 stays in, no x's stay in. All right? So make sure you put your index there too, by the way.
When you divide, you subtract the.
Yes, when you divide variables, you subtract their exponents. Yes. actually did this in geometry a lot when we did like special right triangles and we did trigonometry when we'd have to rationalize the denominator. Rewrite so there are no radicals in the denominator. Leaving a radical in the denominator is not proper math. Like you wouldn't want to leave 2/4 as your answer. You would say 1/2. And so rationalizing the denominator is a way of simplifying it, getting a radical out of the denominator. The way you do it is you just make the denominator not have a radical. And so if you have like a square root, you are going to multiply it however many times your root is. It's a square root. I'm going to make sure it's square root of 3 times square root of 3. That will get rid of it. If I do that to the bottom, I have to do that to the top, just like when you're simplifying. If you do a fraction with something over itself, you haven't changed the fraction, right? So square root of 2 times square root of 3, that's just square root of 6, right? And square root of 3 times square root of 3 is just 3. All right? If you do it enough times, it goes away. If this had been the cubed root, I would have done square root of 3, square root of 3. I would have made sure it's 3 of those so that I would have had square root of 3 times square root of 3 times square root of 3, because then it would have been a cubed root instead, and you would have had the 27 there. So you do it as many times as you have it, all right? Whatever my index is, 2, I'm going to make sure I multiply it that many times by itself, and that will get rid of my radical. But if I do that on bottom, I have to do that same thing on top, all right? So look at this one, this next one. This is a square root, so I have to multiply the whole thing by that group one more time. 1, 2, square root. But I also have to multiply the top by that same thing, all right? And then I'm going to simplify it. On the top, I will have 5x to the fourth y. And on the bottom, I'll just have 5xy. Now the top can actually be simplified. What can be simplified out of the top?
The x.
The x, right? It's an even power there. X to the fourth, I take the square root. What comes out?
X squared.
Right, so x squared will come out, and I will be left with just 5y. On the bottom, I have 5xy. I can reduce, all right? And I'm going to show you one other way we could have done this. So I end up with x square root of 5y over just 5y, all right? I could have taken this and reduced it first, just like we were doing a minute ago. 5xy, right? When I reduce it this way, this becomes 2. This becomes 1, right? Now I can split it back up. Square root of x squared over square root of 5y. My x squared can simplify, right? Square root of x squared is just x. So I have x over the square root of 5y. And then you can radicalize that again, and you'll get the same answer, all right? So you can simplify first or do your rationalization of your denominator first, as long as you simplify when you can. So if I did this first right here, I should recognize that my x to the fourth can actually simplify. If I simplify first, then I just need to rationalize it at the end so I don't have a radical in the denominator. All right, so simplify and rationalize. You're going to be doing both, and it doesn't matter which order you do it in, whichever makes it easier. All right, so try just A and B there. Just A and B. Just A and B. We're not going to do C.